Hi, welcome to this video series on cart and decision trees. In previous videos, we had developed basic intuition for cart. We saw how the cart works on a loss function, which is Gini's impurity. We worked out an example. We discussed in general what are regression and classification types and how cart is a powerful tool which can be used to solve both these problems. We saw why it was under supervised learning. We also gained some intuition on how we go about chopping any given data set to develop then trees, and then we do this by a notion of some amount of purity by measuring how homogeneous a group is. We do this by measuring something called Gini's impurity. We worked out a formula for Gini's impurity. How do we calculate it for each of the group, for each of the chops we make? We also worked through a manual calculation using a toy dataset on how to go about building a decision tree. In this video, I am going to talk about why cart algorithms tend to overfit the data, and then we will discuss some of the common techniques to prevent this overfitting. Now at this time, if you have not watched these earlier videos, now would be the time to pause this video, go back and watch those videos. So if you allow a cart to build these trees and you allow these trees to grow uncontrollably, what might happen is a decision boundary which looks like this. You see, cart is just working on one minimization problem. It optimizes by chopping the decision space such that Gini impurity is at its lowest. So logically, when the algorithm is allowed to chop uncontrollably, it will chop the space in so many ways that each of the ultimate nodes would be left with zero Gini's impurity. Each of the end nodes would be left with just homogeneous class of elements. So if you see here in this graph, the way the algorithm has made these chops is by chopping it so many times that each of the boxes has just one type of observation or one class of elements. Now it's not too difficult to understand when an algorithm does that. It's not only capturing the information in the data, but it's also capturing the noise. You might end up with trees which are so deep and long that they do extremely well with the training data. However, they fail to generalize because they have captured the noise as well. One of the ways and techniques by which we can prevent this is called pruning, and this is the most commonly used approach. Pruning is a method by which we start with a very deep tree and then we cut it to an appropriate size. Pruning uses a concept of cost complexity. Think of cost complexity as every time a branch is created, it is a measure of the increase in the purity or the decrease in the error rate. So if the decrease in error rate or the misclassification after each branch does not exceed a threshold, then the branch is no longer pursued. This way, we have some constraint imposed on our decision tree algorithm, and it does not allow it to chop it very deep. And this is one of the most common ways by which we prevent overfitting. And in our next video, I'm going to show a hands-on Jupyter Notebook example where we work through two data sets. One data set would be iris. I would work the algorithm on iris data set, show you when allowed to grow uncontrollably how much the data gets overfitted. We will show how powerful these algorithms are, and then we pick up another data set where we show how can we prune this algorithm for to allow it to generalize better. Thank you guys. If you have not liked and subscribed these videos already, please do so. If you like these videos, I would love to hear some comments on what do you think about these videos. Thank you.